The whistling sound cut through the French morning air like a blade through silk. High above the coastline near Dieppe, something massive was descending through the cloud cover. The date was April 15th, 1943. The altitude read 20,000 feet on the instruments. Inside the cockpit of the Republic P-47 Thunderbolt, leather-gloved fingers gripped the controls with fierce determination. Major Donald Blakesley had been waiting for this moment. His eyes tracked movement below. The distinctive outline of an enemy fighter broke through the gray wisps of cloud. Weeks of mechanical failures had plagued the squadron. Training flights had been cancelled repeatedly. The massive American fighters had earned mockery from British pilots. 7-ton milk bottles, they called them. But today would silence the critics. Today, the 4th Fighter Group would finally meet the Luftwaffe in combat. The German aircraft came into view through the gun sight. A Focke-Wulf 190 from Jagdgeschwader 26 Schlageter. The pilot had no idea he was about to become part of aviation history. Neither did the American above him. History was about to be written in the sky over occupied France. At 300 yards distance, Blakesley made his decision. His finger found the firing button. 8 Browning AN M2 50 caliber machine guns erupted in perfect synchronization. The sound was unlike anything heard before in aerial combat. Each gun fired at 800 rounds per minute. The mathematical reality was staggering. 6,400 rounds per minute of theoretical firepower. Armor-piercing incendiary ammunition streaked toward the German fighter. The Focke-Wulf carried its own impressive armament. 2 20mm MG 151-20 cannons, 2 7.92mm MG 17 machine guns, pride of the Luftwaffe. Engineering excellence refined through years of combat experience. None of it mattered. The concentrated stream of American ammunition tore the German fighter apart in seconds. Metal fragments scattered through the morning sky. Smoke and flame marked where moments before a sophisticated fighting machine had existed. The P-47 had claimed its first aerial victory. Air combat would never be the same. This moment represented more than one pilot defeating another. It symbolized a fundamental shift in warfare philosophy. The Americans hadn't simply built another fighter aircraft. They had created an airborne weapons platform that would redefine combat through sheer industrial abundance. Where others counted bullets, Americans would spray them like water from a hose. The story behind this victory had begun months earlier. March 10, 1943, marked the P-47's first operational mission. The 4th Fighter Group had flown a fighter sweep over occupied France. Radio equipment malfunctioned continuously throughout the sortie. The mission ended in frustration and early return to base. British radio sets had to be installed to solve the communication problems. Those early months of 1943 proved challenging for American pilots. The 4th Fighter Group consisted of former RAF Eagle Squadron pilots. These men had grown accustomed to nimble Spitfires. The P-47 Thunderbolt felt like a flying freight train in comparison. Empty weight alone reached 12,131 pounds. Fully loaded, the beast weighed 17,500 pounds. This exceeded twice the weight of a Messerschmitt Bf-109G. Republic Aviation's factory in Farmingdale, New York, was producing these massive fighters at unprecedented rates. The production numbers seemed impossible to European observers. By April 1943, one P-47 rolled off the assembly line every 4 hours. Production rates accelerated each month as workers refined their techniques and machinery operated more efficiently. Alexander Kartveli deserved credit for this remarkable aircraft. The Georgian-born chief designer had approached fighter development with revolutionary thinking. His philosophy seemed absurd to European engineers steeped in traditional weight-saving measures. Maximum firepower through maximum production capacity. simple concept. Revolutionary implementation. German designers agonized over weight savings measured in individual grams. Kartveli added guns, ammunition, armor plate with apparent abandon. The result challenged every assumption about single-engine fighter design. Colonel Hubert Zemke understood the American approach better than most. His 56th Fighter Group had arrived in England during January 1943. By April, they were flying regular combat missions. The 56th would become unique among 8th Air Force units. They flew P-47s exclusively throughout the entire war. No other fighter group remained loyal to a single aircraft type. Their eventual tally of 674 aerial victories proved the wisdom of specialization and the effectiveness of American firepower philosophy. The mathematics of P-47 firepower were straightforward but staggering. Early P-47C and P-47D models carried 350 rounds per gun. 8 guns meant 2,800 rounds total. 4 guns per wing created convergent fire patterns. At 250 yards distance, all bullet streams intersected in a concentrated killing zone. The firepower density within this zone exceeded anything previously seen in single-engine fighter combat. A 1-second burst delivered 107 half-inch projectiles. Each bullet traveled at 2,140 feet per second. The kinetic energy was devastating. Even near misses could damage enemy aircraft through shock waves and fragments. Direct hits virtually guaranteed destruction. The volume of fire created multiple impact points that overwhelmed structural integrity. Luftwaffe intelligence initially refused to believe reports of P-47 armament. 8 heavy machine guns on a single-engine fighter seemed technically impossible. German engineering philosophy emphasized efficiency above all else, the minimum armament necessary to destroy enemy aircraft while conserving weight for performance and maneuverability. The standard Focke-Wulf 190A5 represented German thinking. 2 7.92mm MG, 17 machine guns with 1,000 rounds each. 2 20mm MG, 151-20 cannons with 250 rounds each in wing roots. The 20mm explosive shells were individually more destructive than 50 caliber bullets. But limited ammunition supply of only 500 cannon rounds demanded precise marksmanship and careful ammunition management. German pilots had developed sophisticated attack techniques based on ammunition conservation. Short, precise bursts at close range. Maximum effect from minimum expenditure. This philosophy had served well against British fighters. Spitfires and Hurricanes typically carried 8 .303 rifle-caliber machine guns. Sometimes combinations of machine guns and cannons appeared, but always with limited ammunition supplies. The reality of facing P-47 firepower forced immediate tactical adjustments. Following Blakesley's first victory on April 15th, encounters between American and German fighters increased dramatically. April 17th saw P-47s of the 4th Fighter Group flying their first bomber escort mission. Range limitations with early drop tank configurations forced premature return to base. But the psychological impact on German pilots was immediate and profound. 8 guns firing simultaneously created visual effects, unlike anything previously encountered in aerial combat. The P-47's standard ammunition loading sequence followed a specific pattern. 4 armor-piercing incendiary rounds. 1 tracer round. This meant every 5th projectile glowed visibly in flight. The result appeared as continuous beams of light rather than individual bullets. Streams of fire reached across the sky like deadly searchlight beams. By May 1943, captured P-47 components reached the Luftwaffe's Rechlin Test Center. German engineers examined American manufacturing techniques with growing amazement. The Browning AN-M2 machine gun dated to 1933 design, but mass production had refined it to unprecedented reliability levels. Parts were truly interchangeable between any guns. Any component from any weapon would fit perfectly in any other. German industry could never achieve such standardization. The ammunition feed system used disintegrating link belts, empty links ejected cleanly from aircraft during firing. German fighters relied on either drum magazines limited to 60 to 200 rounds or belt systems that retained links. Retained links added weight and created ejection problems. The American system's reliability meant pilots could fire their entire ammunition load in one continuous burst, if necessary. American ammunition production scales stunned German analysts. By mid-1943, the 8th Air Force was flying over 200 P-47 sorties daily. Each aircraft carried 2,800 rounds. Pilots typically expended 60% of their ammunition per mission. This translated to approximately 336,000 rounds fired daily by P-47s alone. More ammunition than the entire German fighter force in France received weekly from supply depots. The Lake City Army Ammunition Plant in Missouri had reached production capacity of 1.6 billion rounds annually by 1943. This single facility outproduced Germany's entire small arms ammunition industry combined. The plant operated continuously with 20,000 workers in rotating shifts. Quality control standards rejected any round varying more than 0.001 inches from specifications. Such precision at such volume defied German comprehension. Republic Aviation's production was equally impressive to enemy observers. The Farmingdale plant covered 765,000 square feet of factory space. Additional production facilities operated at Evansville, Indiana. Combined output reached over 400 P-47s monthly by late 1943. German fighter production of all types struggled to exceed 1,000 aircraft monthly during the same period. German fighter doctrine emphasized lightweight, maneuverable aircraft above all other considerations. The Messerschmitt Bf-109G weighed 6,140 pounds, fully loaded. The Focke-Wulf 190A5 reached 9,040 pounds maximum. The P-47C weighed 13,500 pounds loaded. The P-47D reached 14,500 pounds, impossibly heavy by traditional German engineering standards. Yet the P-47's Pratt & Whitney R2800 engine produced remarkable power. Initial models generated 2,000 horsepower. Later variants reached 2,300 horsepower. Power-to-weight ratios remained competitive despite the massive airframe. The extra weight provided benefits German designers had never considered: stability as a gun platform, ability to absorb tremendous battle damage, and continue flying. The General Electric turbo-supercharger system alone weighed 845 pounds, nearly equal to the entire armament weight allowance on German fighters. But this system maintained full engine power at 30,000 feet altitude. The BMW 801 radial engine in the FW190 lost significant power above 20,000 feet. High-altitude performance became crucial as bombing altitudes increased throughout the war. The shock of facing P-47 firepower forced immediate Luftwaffe tactical changes. Traditional attack methods became suicidal when P-47s provided escort. American fighters didn't require optimal firing positions for effectiveness. Their volume of fire created kill zones German fighters couldn't survive crossing. Single P-47s could engage multiple enemy aircraft simultaneously through firepower density alone. Luftwaffe units developed new tactics emphasizing the FW-190's superior roll rate and turning ability at low altitude. But reaching low altitude required diving through the P-47's fire envelope. American pilots learned to exploit altitude advantage and firepower superiority to force German fighters into unfavorable positions. The tactical initiative shifted decisively to American formations. The contrast in ammunition philosophy was stark and decisive. German pilots entered each combat with 60 to 90 seconds of total firing time available. P-47 pilots possessed 30 to 35 seconds of continuous fire capability. But American pilots could fire liberally while Germans counted every round. This disparity created fundamental tactical differences that affected every engagement. Germans conserved ammunition through precise shooting techniques. Americans relied on volume of fire to guarantee hits. The mathematical advantage lay with American methods. Poor shooting could be compensated through quantity. German pilots required exceptional marksmanship skills that few possessed under combat stress conditions. August 17, 1943, brought the first Schweinfurt-Regensburg mission. This operation demonstrated both P-47 capabilities and limitations simultaneously. Within escort range, P-47s devastated German interceptors attempting to reach the bombers. The 56th Fighter Group alone claimed 17 victories without suffering a single loss. Overwhelming firepower superiority produced overwhelming tactical results, but P-47 range limitations became apparent during this mission. Even with 75-gallon belly tanks, escort range reached only approximately 375 miles from base. German tactics evolved quickly to exploit this critical limitation. Luftwaffe controllers waited until P-47 escorts departed before launching concentrated attacks against unprotected bombers. The resulting bomber losses were catastrophic. 60 B-17s failed to return from the mission. These losses highlighted the urgent need for longer-range escort capability. But within the P-47's protective envelope, bomber losses approached zero. The firepower deterrent effect was complete and decisive. Progressive introduction of larger drop tanks extended P-47 range gradually. 108-gallon tanks appeared by September 1943. 150-gallon tanks followed by October. Each extension pushed escort range farther into enemy territory. By October 1943, P-47s could escort bombers 425 miles from their bases. Each mile of additional range meant German fighters had to wait longer and fly farther before engaging bombers. The infrastructure supporting P-47 operations reached industrial scales that defied German comprehension. Each P-47 squadron maintained ammunition reserves of 500,000 rounds. Forward airfields in England stockpiled millions of rounds in underground storage facilities. Supply ships delivered ammunition continuously from American factories operating at maximum capacity. A typical P-47 group possessed sufficient ammunition for 30 days of maximum intensity operations without resupply from depots. German fighter units operated on 3-day ammunition reserves when supplies were available. Often reserves dropped to single-day supplies due to transportation difficulties and production shortages. American pilots fired liberally during combat encounters. German pilots counted every single round expended. This psychological pressure affected German tactical decisions significantly. Conservative ammunition usage limited aggressive maneuvering and prolonged engagement times. American pilots experienced no such constraints on their combat effectiveness. Maintenance supply disparities showed similar patterns throughout all operational areas. American depots maintained complete replacement engines, gun sets, and major components in substantial quantities. Damaged P-47s could be completely rebuilt from spare parts inventories within days. Operational readiness remained consistently high despite combat losses and battle damage. German units increasingly cannibalized damaged aircraft for spare parts to keep other machines operational. This reduced overall squadron strength even when airframes could theoretically be repaired, given adequate parts supplies. Maintenance became increasingly problematic as the war progressed and supply lines deteriorated. October 14, 1943 marked Black Thursday. The Second Schweinfurt raid became a turning point in the strategic bombing campaign. P-47s flew escort to maximum range, claiming 21 German fighters destroyed. But bombers faced devastating attacks after escort fighters departed due to fuel limitations. German pilot reports from this period revealed growing concern about engaging P-47 formations. The mathematics were irrefutable and psychologically devastating. A German fighter squadron of 12 aircraft might possess 7,000 rounds total across mixed calibers. A single P-47 squadron of 16 aircraft carried 44,800 rounds of heavy machine gun ammunition. Millions more rounds waited in reserve storage. The firepower advantage was amplified by significant training differences between air forces. American P-47 pilots arrived in combat theaters with over 400 flight hours logged. This included more than 100 hours of specialized gunnery training. They had fired thousands of practice rounds at various targets under controlled conditions. German pilot training by late 1943 averaged only 110 flight hours before combat assignment. Perhaps 20 hours consisted of gunnery training when fuel was available for such exercises. Fuel shortages meant many German pilots entered actual combat, having fired their aircraft weapons only a few times during training. German pilots faced American opponents who had expended more ammunition during peacetime training than German pilots would fire during their entire combat careers. The experience gap widened continuously as veteran American pilots survived tours and returned to train replacement pilots with combat-proven techniques. Lieutenant Colonel Francis "Gabby" Gabreski would become the leading P-47 ace in the European theater, with 28 confirmed victories. His description of P-47 tactics was characteristically direct. "We didn't need to be better shots than them. We needed to put our sight on them and hold the trigger down. The 850s did everything else for us." By November 1943, P-47 groups began emphasizing ground attack missions after completing bomber escort duties. The 50 caliber guns proved devastatingly effective against locomotives, vehicles, and parked aircraft. Armor-piercing incendiary ammunition could penetrate locomotive boilers and vehicle armor plate with ease. A single P-47 could destroy an entire train during one strafing pass. The standard attack profile involved a 30-degree dive angle. Pilots opened fire at 1,000 yards distance. Rudder pedals were walked to spray bullets across the target area. Pullout occurred at 200 feet altitude. In 10 seconds, a P-47 could deliver 1,000 rounds into a target area 100 yards long. German transportation networks faced systematic destruction from these ground attack missions. P-47s destroyed locomotives faster than German industry could manufacture replacements. By December 1943, German military units avoided rail movement during daylight hours due to P-47 interdiction effectiveness. The P-47's crucial role in the strategic bombing campaign cannot be overstated. While the P-51 Mustang would eventually assume primary long-range escort duties, P-47s provided the initial protective shield that allowed the bomber offensive to continue despite prohibitive losses. By early 1944, improved P-47D variants carried 425 rounds per gun. Total ammunition load reached 3,400 rounds. The P-47D-25 introduced bubble canopy design for improved visibility. Paddle blade propellers increased efficiency. Provisions for rockets supplemented gun armament. These improvements maintained P-47 combat effectiveness even as German fighter technology advanced. June 6, 1944, provided the ultimate demonstration of P-47 capabilities. D-Day operations saw P-47s fly 2,398 sorties over Normandy. They claimed 84 German aircraft destroyed in aerial combat. 89 more enemy aircraft were destroyed on the ground during strafing attacks. More significantly, P-47s paralyzed German ground movement through systematic interdiction missions. The Luftwaffe managed only 319 sorties over Normandy throughout the entire D-Day period. American forces flew over 13,000 sorties during the same time frame. German fighters operating over Normandy possessed perhaps 200,000 rounds total for all aircraft combined. American fighters alone carried millions of rounds with unlimited resupply capability from established supply chains. P-47s created free-fire zones where anything moving during daylight hours was systematically destroyed. Vehicle columns were reduced to burning wreckage during single strafing passes. The distinctive whistling sound of diving P-47s became a psychological terror weapon. Air flowing through gun ports and cooling ducts created an unmistakable acoustic signature. German soldiers learned to dive for cover at the first sound of approaching P-47s. By late 1944, German fighter production actually peaked at 25,000 aircraft annually across all types. But fuel shortages, pilot losses, and overwhelming Allied numerical superiority meant most aircraft never flew operational missions. Those that did reach combat faced odds consistently exceeding 10-1 against survival. The revolutionary Messerschmitt Me-262 jet fighter provided speed advantages over any Allied fighter, but it didn't possess firepower superiority over the P-47. The Me-262's four 30mm Mk-108 cannons carried only 8,100 rounds per gun. Total ammunition load was 360 rounds maximum. While devastating against bombers, the limited ammunition supply and low muzzle velocity made these weapons less effective against maneuvering fighter targets. Jet speed couldn't compensate for ammunition limitations during extended combat encounters. The P-47N, introduced for Pacific theater operations, carried 550 gallons of internal fuel capacity. This single-seat fighter carried more fuel than German medium bombers. The achievement demonstrated American industrial capability to build aircraft that defied all conventional design limitations. Final production numbers reveal the complete story of industrial warfare victory. Total P-47 production reached 15,683 aircraft. Peak monthly production exceeded 400 aircraft from combined manufacturing plants. Total FW-190 production approximated 20,000 aircraft of all variants from 1941 to 1945. Fighter variants of the FW-190 totaled approximately 13,000 aircraft. Each American P-47 was delivered fully equipped with 8 guns and adequate ammunition supplies. German fighters increasingly flew combat missions with reduced armament due to chronic shortages. By 1945, some FW-190s operated with only 2 cannons instead of standard 4 to conserve available ammunition. Republic aviation facilities covered over 1 million square feet of production space. German fighter production operated from frequently bombed facilities with dispersed production methods that reduced manufacturing efficiency significantly. Constant air raid alerts disrupted production schedules and worker morale. Lake City Army Ammunition Plant alone produced 1.6 billion rounds annually. Combined with other facilities including Frankfurt Arsenal and Des Moines Ordnance Plant, American production exceeded 10 billion rounds of 50 caliber ammunition during the war years. German ammunition production for all aircraft weapons totaled approximately 4 billion rounds, including every caliber combined. Americans produced more rounds of their single heavy machine gun caliber than Germany produced of all aircraft ammunition types together. The industrial disparity was overwhelming and decisive. Quality control procedures differed dramatically between the opposing sides. American ammunition underwent multiple inspection stages with rejection rates of 2 to 3% for minor variations. German production, increasingly relying on slave labor and substitute materials, experienced higher malfunction rates that reduced effective firepower significantly. The U.S. Strategic Bombing Survey documented P-47 achievements throughout the European theater. 3,916 enemy aircraft destroyed in aerial combat, 3,222 enemy aircraft destroyed on airfields during ground attacks, 9,000 locomotives destroyed through strafing missions, 86,000 railway cars destroyed, 68,000 motor vehicles destroyed, 6,000 armored fighting vehicles destroyed. These statistics represent strategic impact far beyond tactical success in individual engagements. Transportation infrastructure destruction by P-47s significantly reduced German mobility and logistics capabilities throughout occupied Europe. The Luftwaffe's inability to counter P-47 ground attacks meant American air power operated with near impunity. American pilots who completed 25 mission tours, later extended to 35 and 50 missions, rotated home to train new pilots with combat experience. German pilots flew until killed, captured, or medically incapacitated. No rotation system existed to preserve experienced pilots for training duties. By late 1944, most Luftwaffe pilots were inexperienced novices facing American veterans with hundreds of combat hours. The experience gap widened continuously throughout the final war years. Survival rates for new German pilots dropped dramatically as American pilot quality improved. American training programs incorporated combat lessons immediately through systematic debriefing procedures. German training programs, disrupted by fuel shortages and abbreviated by military necessity, produced pilots with widely varying skill levels facing standardized American tactics developed through combat experience. Beyond raw firepower, P-47s incorporated advanced technologies that enhanced combat effectiveness significantly. The turbo-supercharger system allowed full engine power at extreme altitudes where German fighters lost performance. The R-2800 engine reliability meant consistent performance with 400-hour intervals between major overhauls. The K-14 gun sight, introduced in late 1944, computed deflection angles automatically using gyroscopic principles. Pilots simply framed targets in the sight reticle and fired. The system calculated proper lead angles for hits. German fighters used basic reflector sights, requiring manual deflection estimates based on pilot experience and judgment. Gun heating systems prevented weapon freezing at high-altitude operations. P-47 guns functioned reliably at 40,000 feet in -60 degrees Fahrenheit temperatures. German fighters frequently experienced gun freezing above 25,000 feet, particularly wing-mounted weapons exposed to airstream cooling. American abundance extended throughout all maintenance operations. P-47 groups maintained extensive spare parts, inventories including complete engines, gun sets, and propellers. Ground crews could completely re-engine aircraft overnight when necessary. Battle damage requiring weeks of German repair work was corrected within days. German maintenance became increasingly problematic as the war progressed. Spare parts shortages meant systematic cannibalization of damaged aircraft. By late 1944, Luftwaffe serviceability rates dropped below 50%. American P-47 groups routinely maintained 85% serviceability rates. American crew chiefs were trained specialists with extensive technical education programs. German ground crews, depleted by military conscription, increasingly consisted of foreign workers and Hitler Youth members with minimal training experience. Technical competence declined steadily throughout the war. P-47s burned 130 octane aviation fuel that allowed higher manifold pressures and increased power output. German synthetic fuel produced from coal provided inconsistent octane ratings that reduced engine performance and reliability. Quality variations caused engine problems during combat operations. By late 1944, German fighters received 30-50 gallons per sortie when fuel was available at all. P-47s routinely carried 370 gallons internally, plus external drop tanks. American pilots flew multiple daily missions while Germans were grounded by fuel shortages. German pilots understood that aggressive maneuvering consumed precious fuel needed for safe return to base. American pilots flew without fuel anxiety, enabling aggressive tactics that Germans couldn't match due to supply constraints. The psychological pressure of limited fuel affected every tactical decision. The P-47 represented American industrial philosophy triumphant. Overwhelming quantity of sufficient quality over technical perfection in limited quantities. Where Germans pursued engineering optimization in small numbers, Americans pursued adequate performance in unlimited quantities. Kartvelli's P-47 design prioritized manufacturability over theoretical optimization. The aircraft was easier to manufacture than German fighters despite greater complexity. Standardization and mass production techniques enabled faster production at lower unit costs than traditional manufacturing methods. This philosophy extended throughout the entire supply chain organization. The same 50 caliber rounds fired by P-47s were used by bombers, ground vehicles, and naval vessels. This simplified logistics while achieving economies of scale impossible with diverse caliber requirements. German attempts to match American firepower proved futile given industrial limitations. The FW-190A8, introduced in February 1944, could carry additional cannons in underwing pods, but added weight and aerodynamic drag severely degraded flight performance. The modification created more problems than solutions. The Sturmbuck variant was optimized for bomber destruction with heavy armor and 30 mm cannons. But the aircraft was helpless against escort fighters due to weight penalties and reduced maneuverability. Specialization for one mission type created vulnerabilities in other mission requirements. The fundamental problem remained industrial capacity limitations. Germany could not simultaneously fight a multi-front war and match American production levels. Attempting to do so only accelerated resource exhaustion and industrial collapse. Beyond physical destruction, P-47s achieved decisive psychological victory over German forces. The distinctive whistle of diving P-47s became a terror weapon affecting German soldier morale. Ground troops developed persistent anxiety about P-47 attacks, diving for cover at any aircraft sound. American pilots understood their psychological advantage completely. They flew with confidence derived from unlimited resources and industrial support. German pilots flew with desperation born from scarcity and declining support. This mental state affected every tactical decision and combat outcome. The P-47 achieved an impressive 4.6-to-1 kill ratio during over 746,000 combat sorties. While 3,499 P-47s were lost to all causes, this represented less than 0.5% loss rate per sortie flown. German fighter units suffered 50% monthly casualty rates by late 1944. The 56th Fighter Group, flying only P-47s throughout the entire war, became the top-scoring American fighter group in Europe, with 674 confirmed aerial victories. This achievement demonstrated that supposed P-47 limitations were overcome by firepower superiority, structural durability, and superior pilot training. The P-47's 850 caliber guns represented more than mere firepower statistics. They embodied American industrial philosophy triumphant over traditional military thinking. Each gun required precision manufacturing and complex supply chain coordination. That America could mount 8 per fighter with unlimited ammunition demonstrated industrial supremacy, transcending simple military calculations. Military historians recognize P-47 firepower as decisive in achieving air superiority over Europe. The ability to deliver overwhelming firepower at extended ranges broke the Luftwaffe's defensive capabilities completely. Once air superiority was achieved through firepower dominance, Allied ground victory became mathematically inevitable. The P-47's influence extended far beyond World War II combat operations. It established principles dominating modern air combat philosophy: firepower superiority through volume of fire, standardization enabling mass production, industrial capacity determining ultimate military capability. Modern fighters carrying rotary cannons firing 6,000 rounds per minute are direct descendants of P-47 firepower philosophy. Precision-guided munitions represent evolution, not rejection of overwhelming force principles. Technology has changed. The fundamental concept of industrial superiority remains constant. When West Germany rebuilt its air force during the 1950s, it adopted American equipment, tactics, and doctrine completely. German pilots trained on American aircraft. They fired American ammunition. They absorbed American philosophy. The former teacher learned from the former student. While statistics reveal the strategic story, individual accounts illuminate the human dimension of this technological revolution. Colonel Robert S. Johnson of the 56th Fighter Group survived a devastating attack on June 26, 1943. His P-47 absorbed over 200 bullet holes during the engagement. The aircraft returned safely to base with major control damage and a shattered canopy. That level of structural damage would have destroyed any German fighter completely. The P-47's massive construction and redundant systems enabled survival under impossible conditions. Johnson's experience proved that American engineering philosophy worked under the ultimate test of combat effectiveness. Colonel Hubert Zemke commanded the 56th Fighter Group throughout its combat operations. He developed innovative tactics, maximizing P-47 advantages while minimizing limitations. His Zemke fan formations spread squadrons wide, creating overlapping fields of fire that German fighters couldn't penetrate safely. Under Zemke's leadership, the 56th achieved remarkable success exclusively with P-47 aircraft. They proved that proper tactics could overcome any theoretical performance disadvantages through firepower superiority and coordinated operations. German pilot Heinz Knock authored "I Flew for the Führer" after the war. His memoir described facing P-47 formations as confronting streams of tracers that appeared solid rather than individual projectiles. Making bomber approaches through P-47 escort screens became impossible due to firepower density. Knock's account provides valuable German perspective on American firepower superiority. His descriptions reveal the psychological impact on German pilots forced to confront overwhelming firepower with limited resources and declining support. Behind production statistics were millions of American workers creating the arsenal of democracy. At Republic Aviation's Farmingdale plant, women comprised 40% of the workforce by 1943. These workers built P-47s with precision exceeding peacetime manufacturing standards while maintaining unprecedented production rates. Lake City Ammunition Plant operated continuously, with workers producing billions of rounds in climate-controlled facilities. Quality control inspectors, mostly women, rejected rounds varying even slightly from exact specifications. Their dedication ensured American pilots never experienced ammunition failures that plagued German weapons. American workers earned excellent wages, lived comfortably, and took genuine pride in their contribution to victory. German production increasingly depended on forced labor working in deteriorating conditions. The result was systematic sabotage and steadily declining quality control. The P-47 program cost approximately $1.3 billion in 1940 currency values. This represented massive investment in a single weapon system. Yet American industrial capacity made this expenditure affordable while simultaneously producing thousands of other aircraft, tanks, ships, and weapon systems. American mass production techniques reduced unit costs continuously throughout the production run. Early P-47s cost over $100,000 each. By 1945, unit costs dropped to $83,000, despite increased capabilities and improved equipment. German fighter costs increased throughout the war, as production dispersal and material shortages reduced manufacturing efficiency. Post-war analysis revealed the enormous gulf between American and German production methods. American factories employed specialized machine tools, assembly line production, and statistical quality control procedures. German production retained traditional craft methods completely unsuitable for mass production requirements. The Browning M2 design facilitated mass production through simple, robust components manufactured by semi-skilled workers using automated machinery. German weapons required skilled craftsmen using traditional hand-fitting methods. This fundamental difference meant America could expand production exponentially, while Germany could not. The P-47's 8 guns represented synthesis of every American advantage. Industrial capacity provided the foundation through ability to produce fighters, guns, ammunition in vast quantities. Technology enabled effectiveness through turbo supercharging, reliable engines, precision manufacturing. Logistics delivered materials where needed when needed. Training ensured pilots could exploit these advantages effectively. Germany possessed excellent pilots, innovative technology, and tactical sophistication. But without adequate industrial foundation to support them, these advantages proved insufficient against American material superiority. The Luftwaffe was defeated not by superior individual tactics, but by overwhelming industrial production, symbolized by 8 guns firing continuously. German pilots facing P-47 Thunderbolts learned harsh lessons about modern industrial warfare. Their Focke-Wulf 190s, excellent fighters by traditional standards, were overwhelmed by American firepower delivered through mass production. 850 caliber machine guns, supplied with unlimited ammunition, represented entirely new warfare paradigms. The transformation from confidence through shock to reluctant acceptance mirrors Germany's larger World War II experience. Initial tactical superiority based on innovation and pilot skill crumbled against American mass production and material abundance. The P-47, initially dismissed as too heavy and unwieldy, proved that industrial might could overcome any tactical disadvantages. German pilots were shocked not simply by 8 guns firing in perfect synchronization, but by what those guns represented fundamentally. A nation capable of producing unlimited weapons, ammunition, and aircraft while maintaining quality standards. The Focke-Wulf 190 might have been superior in traditional engineering terms, but traditional terms had become completely obsolete. The P-47's 850s rewrote air combat regulations through pure industrial power and overwhelming firepower. The legacy endures in every modern fighter emphasizing firepower over finesse, every massive munitions expenditure, every industrial approach to military challenges. All trace direct lineage to that moment when German pilots first encountered 8 synchronized Browning machine guns and realized their entire understanding of aerial combat was obsolete. The P-47 Thunderbolt didn't simply outgun the Focke-Wulf 190 in individual combat encounters. It outproduced, outsupplied, and ultimately outthought German aviation philosophy through overwhelming firepower delivered by industrial democracy operating at maximum efficiency. Those 8 guns weren't merely weapons systems, they were messengers carrying news of American industrial supremacy. Every sustained burst demonstrated production capabilities that Nazi Germany could never hope to match. The thunderous roar of 8 synchronized Brownings became the unmistakable sound of inevitable Allied victory, a sound that echoed continuously from American factories to European skies, forever changing the fundamental nature of aerial warfare through industrial abundance.